Hello dear friends, in this video we are going to learn about Pythagoras Theorem, which is very important in your class 10 board examination. The statement is, in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The given is triangle ABC is right angled at angle B. Let me draw. This is right angle at angle B. Now we have to prove that AC square, the hypotenuse square, is equal to sum of the squares of other two sides. That is, AC square is equal to AB square plus BC square. Let us have some construction on this triangle ABC. Construct or draw BD perpendicular to AC. That is, BD perpendicular to AC. This is the line originating from vertex B falling on AC, which is at 90 degree on it, that is perpendicular on AC at point D. This is another view of the same similar triangle. We will now onwards analyze from this angle orientation. Now we have to prove that AC square is equal to AB square plus BC square. To prove that, let us consider two triangles, that is in triangles ADB and ABC. We have angle ADB is equal to angle ABC 90 degree at each of D and B point. That is, at D this is 90 degree and at B this is 90 degree, because we have considered two triangles ADB and ABC. ADB is where? ADB. And where is ABC? ABC. That is ABC. Remember, the in-between letters are actually deliberately kept to show at this point there is 90 degree or right angle at this point only. Now we also have, look at this triangle ADB and triangle ABC. This angle is common to both the triangle. This angle A is contained by both the triangle ADB and ABC. So you can write also angle BAD is equal to angle BAC. Which is common to both the triangles. It means what? It means what? By angle corollary, we have that these two triangle ADB, which we have assumed initially, this triangle ADB is similar to triangle ABC. Just remember, I am going to explain it once again. At point D, the triangle ADB is 90 degree at point D, right angle at point D, and triangle ABC is right angled or having 90 degree at point or vertex or B. See this? This is common to both the triangles. This is common to both the triangles, point A, and at B there will be theta. What theta is going to do here, I am going to explain. Just have patience. Now, dear students, just see in the bigger triangle ABC. In the bigger triangle ABC, this one is the hypotenuse, the bigger hypotenuse. Call it capital H. Call it capital H. Now, this is your perpendicular. Choose this as a perpendicular. So, this is your capital P. In between the hypotenuse capital H and perpendicular capital B, there is angle theta. Now come for the triangle ADB. ADB. Opposite to 90 degree, there is hypotenuse, call it small h. Now this is the perpendicular we have drawn. So in between hypotenuse small h and small p, there is angle theta. There is angle theta. Call it theta 1 or call it theta 2. There is no problem. Okay. Now what we are going to do, we know from the similar triangles results that if two triangles are similar, then their corresponding sides ratio are equal to each other. Now we are going to write from these two triangles AD by AB is equal to AB by AC. Now dear students, some of you may wonder why I have written AD by AB is equal to AB by AC. Just see the clue. This is AD is opposite to the theta 2. See this. AD is opposite to the theta 2 or theta. Or AB is opposite to opposite to your 90 degree angle. This is your 90 degree angle. So this is going to help you a lot. Okay. See this AB in a bigger triangle. AB is in a bigger triangle. This is AB. This is your AB, which is opposite to theta and opposite to 90 degree. This opposite to 90 degree is your AC, the hypotenuse. This one. Now what we are going to do from this, it is equal to AB square is equal to AD into AC. Call it equation number 1. Similarly, for this triangle, we have in triangles BDC and ABC. See this? This is the whole triangle ABC and another smaller triangle which is BDC. See, we have kept the same nomenclature format. At point D, this is 90 degree. At point B, this is 90 degree. This is 90 degree and this is 90 degree. So in these two triangles, angle BDC is equal to angle ABC, that is 90 degree both, and angle BCD is equal to angle BCA, which is common to both. Now, from similar triangles, ratios of corresponding sides are equal to each other, that is, see this is your bigger hypotenuse of the triangle ABC, call it capital H. This is your perpendicular drawn for this smaller triangle ADB. Now this is your perpendicular for this triangle ABC. For triangle ABC, perpendicular is this, hypotenuse is this, and for triangle ADB, hypotenuse is this. This is H, and this is your smaller P, that is perpendicular. Now what we are going to do? Well, keeping the same functions, same trick, that is sides opposite to theta by sides opposite to 90 degree, that is BC by AC is equal to DC by BC. That implies BC is equal to AC into DC. Call it equation number 2. Now what we are going to do? Finally we are going to add equations 1 and 2. That is AB square is equal to AD into AC, and BC square is equal to DC into AC. Add this. This is AB square plus BC square is equal to, look, AC is common to both, so take AC common, AC, so it is AD plus DC. So it is AC multiplied by AD plus DC. See this, AD plus DC is ultimately AC. This is your AC. So AB square plus BC square is equal to AC square. This is your AC square. Ultimately, we have proven that AC square is equal to AB square plus BC square. So we have proven that AC square is equal to AB square plus BC square, or in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Thank you for watching this video. I hope you must have enjoyed the solution, the proof, and the questions related to this Pythagoras theorem is always very interesting. Thank you so much for watching this video.